This is the function yes or no homework. In this homework assignment, you had 20 questions. You had to go through each of these problems and determine if what you were looking at was a function or not. The first set of 6 questions that we have here are ordered pairs. When we're looking at an ordered pair and trying to figure out, is it a function, is it not a function, what we're going to want to do is look at the x values. So that's those first numbers in each pair. In question 1, that's a -1, 0, +1, and 2. And as long as all of the numbers are different, we can say that it is a function. And we're just going to keep doing that until we get some repeat numbers. -5, +5, 0, 3. These are all different numbers, so this is a function. Here we have -2, 6, -2, 0. So you might be able to see here that there's a problem. There was a repeat, -2 and another -2. So I'm thinking that this is not a function. Before I can officially say that though, I also want to look at the numbers right next to it, 7 and -3. Those numbers, if they were the same, then it would cancel out and we could ignore the duplicates. But they're not the same, so this is not a function. Let's keep going. Question number 4. 7, +4, 2, +4 again. So we have those duplicates here, 4 and 4. So probably not a function, but always want to double check. -6, -9, those are different numbers, so yes, this is not a function. Number 5, 2, 2, 2, 2. We definitely have duplicates here. All of these are duplicates. 3, 4, 5, 6. We got different numbers here. This is not a function. And then number 6, 1, 1, 2, 3, 4. We're back to having all different numbers, so this is a function. So this would have been the answers for 1 through 6. Function, function, not a function, not a function, not a function, function. And again, we can see the ones that are not functions because they have duplicates in the x value. Now let's go ahead and look at the next set of problems. Here we have tables. Tables are pretty much the same as ordered pairs. We're going to look at the x's for duplicates. So we have -2, -1, 0, -1, -2. We definitely have duplicates here. Let's start with our first set. -2 and -2. Those are duplicates, but what you might notice, the numbers next to them, 1 and 1, are exactly the same. Whenever that happens, we have duplicates, but the whole thing is a duplicate, the entire row. I can just erase one of those rows to get rid of it. Now I still have a duplicate here though, -1 and -1. But again, the numbers next to them are the same. So I can erase one of those rows as well. After erasing both of those rows, I no longer have any duplicates. So this actually is a function, despite those duplicates in the beginning. 8, we have 5, 2, -6, 3, 0. All different numbers, function. And 9, we have 6, 1, 0, -1, -6, all different numbers, function. So 7, 8, and 9 were all functions. 7 was a little bit tricky because we did have duplicates. But again, the duplicates do not count if the entire row is a duplicate. So if only the x is a duplicate, that is bad. If the x and the y are duplicates, like -2, 1, and -1, -1, then it is okay. We're going to move on to our next section now. So in this next set, we have graphs. And with graphs like this, what we want to do is look to make sure that I can draw a vertical line wherever, and it only go through one point. So I'm going to draw a vertical line, and I'm sort of going to scan the graph. Just make sure that as I'm moving it, it only ever touches one point. So this one is only touching one point at all times. So it is a function. Next graph. And right off the bat, there's an issue here. This graph touches here, here, and here. So that is not a function. Let's check number 3, or the third graph here. 1 point, just 1, still only 1. It's going up, it's going straight, going back down, but 1 the entire time. Function. Starts at the top, moves its way on down, and then moves back up, but only 1 point. Function. Now let's move it. So far, only touching 1 point, right there in the middle, but as soon as I move it even a little bit, we have a problem. It's touching up here and also down there. So this one, not a function. One last graph to try. Just 1 point, but again, like the last one, as soon as I move it even a little bit, it touches twice. Not a function. Another way to think about this, your graph should always be moving towards the right direction. So in the beginning, this one moves and moves. This one, it sort of zigzags back and forth. We don't want that. We want it to always be going in one direction. This one, it's constantly moving to the right. It might move up, might move down, but always to the right. Here, that's good. This one goes backwards, which is bad. Here, not good. But mainly you can just look at that vertical line. If you can draw a vertical line anywhere on that graph and have it go through more than 1 point, it is not a function. Let's take a look at our next images. Now we have some maps. For maps, what you're mainly paying attention to is the left side. What I want to make sure is that each number on the left side So with 16, that's 5, 10, and 15. They should only have one line coming out of them. So here there's a problem because 5 has 2 lines coming out. 10 and 15 are okay. One line, but that 5 messes it up, makes it not a function. Here, -2 has 1, -1 has 1, +1, and +2. They all just have 1, so this is a function. And then for 18, -3 only has 1, but -2 has 2. I don't have to check the rest. Because of that -2, this is not a function. So that's how we tell from maps. We look at those numbers on the left side that have multiple arrows or lines coming out of them. Let's move into the last section, our discrete graphs. Starting with 19, what we're mainly looking for, again, is that vertical line. Is there anywhere I can draw a vertical line and have it go through more than one dot? So as I move it along, 0 dots, 0, 0, 0. This line, there's 1, 0, just 1, 0. Oh no, right here, there are 2 dots. We can only have 0 or 1s. This has 2, so it is not a function. Let's move on to the last question. And let's draw our straight vertical line and move it along. 0, 0, 0, 0. There's 1 at the top, 0, 1 in the top section, 0, 1 in the lower section, 1 in the lower section, 0. So I was able to make my way through the entire graph only hitting 0 or 1 dot. So this is a function. And that is how you tell if things are functions or not. Next video will be on domain and range.